Good morning, students. Today we are discussing about the different allotropic forms of phosphorus. Okay, the three important allotropic forms of phosphorus are white phosphorus, red phosphorus and black phosphorus. Let us discuss the different properties. Okay, properties of phosphorus. Properties. First we are discussing white phosphorus and red phosphorus. Red phosphorus. Okay. Now, state. First point, state. White phosphorus is translucent, soft, waxy liquid. Translucent, soft, waxy liquid. What about red phosphorus? Red phosphorus is a brittle powder. Okay. Second property, for different physical properties we are discussing. Second point is odor or smell. White phosphorus is garlic smell and red phosphorus is odorless. Okay. Third point, color. White phosphorus is pure white in color and red phosphorus is red in color. Fourth point, what about their melting point? White phosphorus 44 degrees Celsius and red phosphorus sublimes at 290 degrees Celsius in the absence of air. Okay, absence of air. Next point, their solubility. Solubility in water. Both white phosphorus and red phosphorus are insoluble. Okay. Next, in carbon disulfide, their solubility is white phosphorus is soluble and red phosphorus is insoluble. Okay. Also, white phosphorus is a poisonous liquid. Okay. And it also shows chemiluminescence. What is chemiluminescence? Chemiluminescence means they glows in dark. Okay, that's an important property of white phosphorus. Now, let us discuss the different chemical properties. Okay. So, next property is reactivity. Reactivity. White phosphorus is very reactive and red phosphorus is less reactive. Very reactive, less reactive. Next point, air. Burns in air. What about white phosphorus? It readily catches fire. Readily catches fire and forms P4O10, that is P4 plus 5O2. The reaction will be P4 plus 5O2 gives P4O10. So, white dense fumes is obtained. It readily catches fire and form dense white fumes. Here also it forms P4O10. Okay. Next reaction, next property, next is molecular formula. What about its molecular formula? Its molecular formula, it's P4 and this is a complex polymer. The shape will be like this. 4 phosphorus on 4 direction, 4 sides, okay? Phosphorus. Okay. 60. So, it exists as P4 and the structure will be like this. But here, it's a complex structure. Like this it goes. Okay. So, these are the structure, molecular formula of white phosphorus and red phosphorus. Next, reaction with Cl2. With Cl2, it reacts spontaneously. White phosphorus reacts spontaneously. Okay. And form PCl3 and PCl5. Here, it reacts on heating. Form PCl3 plus PCl5. Okay. Next, white phosphorus also reacts with boiling NaOH. It dissolves in boiling NaOH in an inert atmosphere and gives phosphine. Okay. White phosphorus reacts, that is P4 plus 3 NaOH. Reacts with, dissolves in boiling NaOH in an inert atmosphere and form plus 3H2O. Okay. Gives PH3, this is phosphine, plus sodium hypophosphite, 3NaH2PO2. Sodium hypophosphite is obtained. Okay. So, these are the different reactions of white phosphorus and red phosphorus. Now, some special properties of red phosphorus. There are some special properties of red phosphorus. That is, red phosphorus obtained by heating white phosphorus at 573 Kelvin in an inert atmosphere for several days. Okay. How can we obtain red phosphorus? Produced by heating white phosphorus at 573 Kelvin, okay, in an inert atmosphere for several days. Okay. For several days, we can obtain red phosphorus. Next, when red phosphorus is heated, what happens? Under high pressure, we can obtain black phosphorus. Red phosphorus heated under high pressure. We can obtain black phosphorus. Okay. We can obtain black phosphorus. Now, what are the important properties of black phosphorus? Black phosphorus it possesses iron grey luster. Its appearance is iron grey luster. Okay. It is non-poisonous. It doesn't have any chemiluminescence. No chemiluminescence. Okay. Now, black phosphorus are of two types. There are two forms of black phosphorus, alpha black and beta black. Two forms of black phosphorus. How can we obtain this? Alpha black is formed when red phosphorus heated in a sealed tube at 803 Kelvin. Okay. It can sublime in air and has opaque monoclinic or rhombohedral crystal. Okay. First, alpha black. How can we obtain? Alpha black can be obtained when red phosphorus heated in a sealed tube at 803 Kelvin. Okay, we can obtain alpha black. What is its property? It can sublime in air, and it has an opaque monoclinic structure. Its structure is opaque monoclinic, or we can say rhombohedral crystals. It's a rhombohedral crystals. Okay, rhombohedral crystals. What about beta black? Beta black is prepared by heating white phosphorus at 473 Kelvin under high pressure. Heating white phosphorus at 473 Kelvin under high pressure, we can obtain beta black. Okay. Now, its property, it doesn't burn in air. Up to 673 Kelvin, it doesn't burn in air. Doesn't burn in air at about 673 Kelvin. Okay. These are the important allotropic forms of phosphorus. Okay.